Hi there, Rachel Chase here, and in this final video in the series of hypothesis testing, we will explore testing claims when we're dealing with proportions. Now, if you recall from confidence intervals, remember proportions are a way for us to test things about qualitative data instead of just dealing with quantitative data. Now, proportion testing always uses Z, so this is kind of a throwback to the sigma known situation. However, the formula is very different because we are dealing with sample proportions and population proportions instead of means. The formula for this is given by p hat minus p divided by the square root of p times q divided by n. And quite frankly, I would advise that you become very familiar with your technology for this. While it's perfectly acceptable to be able to plug this in and use this formula by hand, I can show you what it looks like. Truth be told, many people make mistakes just typing this in because of the amount of parentheses you would need. So I'll show you how to do that. However, I would advise that you get familiar with your test functions in your calculator. Let's look at an example here. A study of HIV infection rates among IV drug users reported the rate of new infections steadily dropped over the last couple of decades. The latest report was that 2% of IV drug users are HIV positive. A drug counselor believes this trend is continuing and that the percentage of IV drug users in a city who are HIV positive is now less than 2%. In a simple random sample, that's what SRS stands for, of 415 IV drug users in the city, he finds that 8 are HIV positive. Does this evidence support the counselor's belief? Use a zero point zero 0.01 level of significance. So for starters, let's go through the information that they've told us. The latest report tells us, so that is the population proportion, that 2% are HIV positive. He believes the trend is continuing and it's actually less than 2% now. The simple random sample of n equals 415 drug users, IV drug users that is, we find that 8 are HIV positive, that is X. So what is our p hat? P hat is 8 over 415. If p is 0.02, q is the complement, 0.98. Testing this at a 0.01 level of significance. So what information do we know here? To support his belief, it means that the IV drug usage rate is actually decreasing. So that's a way of indicating that we are looking at a one-tailed test. So our null hypothesis is that the proportion is equal to 2%, the population proportion. And the alternative hypothesis is that it's actually less than that amount, that there's a decrease in drug usage. So if this is alpha equals 0.01 in the tail region, I'd like to show you how you'd go about setting this up if you did want to do your test statistic by hand, but please keep in mind I advise you use technology here. The z-test is going to equal 8 over 415 minus 0.02, all divided by the square root of 0.02 times 0.98 over n is 415. So as you could probably already start to imagine, there's a lot of parentheses that are required here. To use your test function in the calculator, and this will just give you the number for your test statistic, you don't have to try and type that in. You're going to go to your stat tests and look for the one proportion z-test. For us, it will only ever be one proportion. We have a p naught of 0.02, so that's 2%. X is 8 drug users, HIV positive, out of the 415 total drug users. And we're testing to see if there has been a decrease over time. So we use less than. So that's what it looks like here. When you calculate, you'll notice that it gives you same information as all of the other test functions have. Now, the nice thing about using the p-value method is that you don't have to go and find your critical value, although you could do that if you wanted, in which case you would use either the z-table or the inverse z functions on your calculator, the inverse norm functions. So what has this given us here? It gave us a z-test score of negative 0.105. We have a p-value. I know this can be a little confusing because they give us p and then p hat. This p-value, this p, is the p-value we're referring to. is 0.458, and we want to compare that to alpha. When our p-value of 0.458 is greater than 0.01, which is alpha, if you recall, anytime the p-value exceeds alpha, we fail to reject our null hypothesis. So what does that mean in context? We do not have sufficient evidence that the HIV infection rates are actually lower, or it's not necessarily decreasing as this person must have originally thought. Again, keep in mind that hypothesis testing is used to diagnose, but it doesn't tell you the details of that process. So let's go ahead and do one more. According to a report published by the MAA, 1% of bachelor's degrees awarded in the U.S. are in math and statistics. One recent math graduate believes that this number is incorrect. She takes a simple random sample of 12,317 recent graduates for her sample and finds that 148 received math or stats degrees. Does this evidence support the claim that the percent may not be 1%? Test this at a 0.10 level of significance. It's actually a really insignificant amount. You're saying basically 10%. It's not a big deal, and that's okay. Remember, from confidence intervals, the smaller this number, the more strict the test results have to be. So they're claiming that 1% are awarded in math and stats. She thinks the number is incorrect, and her sample says that 148 out of 12,317 did in fact receive those degrees. Test the claim at a 0.10 significance level. Does it matter if it's above or below that number? No. She's just looking to see, are those values incorrect? There's no direction to that, so you're going to use a two-tailed test here. So split this in half, that's 0.05, 0.05, just for the visual sake. The rest of it doesn't necessarily matter. Our null hypothesis is that the proportion is equal to 0.01. Our alternative hypothesis is that the proportion does not equal to 0.01. Using our one proportion z-test, like we just learned how to go through, testing the claim that it's 1%, 148 out of 12,317, and this is two-tailed. So to make our final decisions here, we have a z-test of 2.249 and a p-value of 0.025. You'll notice I always write the p-val because when we're dealing with something like p for population proportion, you don't want to mix those two up. And then look, is 0.025 bigger or smaller than alpha, which is 0.10? So go back to the original here. 0.025 is less than alpha, which means that we have sufficient evidence to reject our null hypothesis. As you can probably see by this point, there's a lot that goes with hypothesis testing that you'll get better at as you practice. That said, the process is the same for each. The technology does help us a bit, and the choice is yours whether you'd like to use your calculators for that or your tables. It's entirely up to you. Thanks for watching.